Okay, so we're going to be diving into the 6 trig ratios, okay, and how they relate. Okay, so we've gone over the 6 different trig ratios themselves. We have sine, cosine, tangent, those you know. Okay, then we have cosecant, secant, and cotangent, which are the reciprocal functions of sine, cosine, and tangent. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay? All right. So let's add this to our quadrants. Okay? So these are the 4 quadrants that we've been dealing with forever and ever and ever, the Cartesian coordinate system. This is your x-axis, this is your y-axis. Okay? Now, things that we know. Well, we know in the first quadrant, okay, all of our points are in the form xy. So here, x is positive, y is positive. So in the first quadrant, we know both x and y are positive. In the second quadrant, x is negative, y is positive. And the third quadrant, they are both negative. And then in the fourth quadrant, x is positive, y is negative. Okay? Now this is going to become important in just a minute. Okay? Because when we go back up here, these 6 trig functions, notice that we have sine is y over r. Okay? And using this triangle, y is my vertical and x is my horizontal in this triangle. Okay? It also means the same thing down here. Okay? So what I'm going to do is, if I draw my triangle in my circle, so this right here is my triangle where this is the angle right here. Okay? That means this side is my y, this side is my x, this side is my r, which makes this coordinate right here xy. Okay? We'll talk about that more later. But that also means that when I look at my trig ratios, depending on which quadrant I'm in, depends on if they are positive or if they're negative. So in the first quadrant, y and x are both positive. So in the first quadrant, all of my trig functions are going to be positive. Now, if we look over in this quadrant, in the second quadrant though, here, and I draw this triangle this way, this is y, this is x, and this is r, okay, and this is my angle here. In this quadrant, x is negative. So that means that in this quadrant, cosine would be negative and sine would be positive. So in this quadrant here, so in the first quadrant, all of them are positive. Okay? In the second quadrant, sine is positive, because if x is negative here in the second quadrant, that means sine is positive, cosine is negative, and tangent would be negative because it would be a positive divided by negative. In the third quadrant, tangent is positive because sine and cosine will be negative because x and y are negative, but y over x, negative by negative, is positive. And in the fourth quadrant, cosine is positive. Sorry. Okay? So this is going to become important. Okay? Knowing which trig function is positive or negative in which quadrant is going to be really, really important. Okay? Now, the other thing is, if sine is positive, then cosecant is positive, because r can never be negative. Okay, so that's a big thing that you need to write down. Okay, I mean, it should be, self-explanatory, because r stands for the radius, right? So the radius is never negative. Okay, how would you even draw a circle with a negative radius? Okay, how would you draw a -1 radius? In the Cartesian coordinates, you can't. When you deal with polar coordinates that we'll deal with at the end of the year, then you can have negative radiuses, but we'll talk about that more later. But in this case, when we're dealing with the trig functions, r cannot be negative because you can't have a negative radius. Okay, so you need to remember that in the first quadrant, all of your trig functions are positive. Okay, in the second quadrant, sine is the only one that's positive. In the third, tangent. In the fourth, only cosine. Okay, and there's a bunch of different acronyms a bunch of teachers use. The one I always talk about is all students take calculus. A for all, S for sine, T for tangent, C for cosine. All students take calculus. So that's an easy way of remembering it. Okay. So how is this going to help us? Well, all of these things combined, knowing how they relate using this triangle and the circle and the quadrants, allows us to do problems like this. Okay, so if sine theta is 3/5 and is in quadrant 1, what is the value of tangent theta? Okay, so there's two things that we have to practice here. One, we need to practice setting up the quadrant. Okay, so we're in quadrant 1, so I'm going to draw my x and y. My sine value is in quadrant 1. So in quadrant 1, we draw this triangle, where this angle right here is my reference angle. Remember, reference angles are the angles from the terminal side to the x-axis. So your triangle should always be sitting on the x-axis like this. Now, it says sine theta is 3/5. Well, going back to our ratios, sine theta is y/r. Okay? So, my y value is 3 and my r is 5. So I put my 3 here because it's the y and 5 here because it's my r. I don't know what x is though. Okay? They want to know what tangent theta is. Well, okay. Tangent theta is y/x. So that's from up here in these ratios. So right here, tangent theta is y/x. Sine theta is y/r. You have to know these, okay? Just have to know them. So, well, I already know what y is. I know y is 3. So I know this is 3 over something, whatever x is. Well, I need to find x. Well, gosh, I wish I had some kind of formula that if I have two sides of a right triangle that I can find the third side. Oh wait, I do. It's called Pythagorean Theorem. So we've got to do Pythagorean Theorem to figure out my third side. Well, that means 5 is my hypotenuse, 3 is one of my legs, so I get 3 squared plus b squared equals 5 squared, because this is a squared plus b squared equals c squared. Okay? So solve for b. So b squared equals 25 minus 9, because 5 squared is 25, move the 3 over. So you get b is the square root of 25 minus 9, which is 16. So b is 4. And technically we should write plus or minus 4, because when you take the square root, when you do this, the square root of something squared, you get plus or minus. But we know, since we're in the first quadrant, that b is positive. So this is positive 4. So that means my tangent is 3/4. Okay? So the hardest part about these problems is setting up the triangle correctly. Pythagorean theorem, easy. Knowing the ratio, memorization. So there's really not that the math itself is not difficult. It's the concept and knowing what to do and how to set up this triangle. Okay, let's do one more. So tangent theta is negative 5 over 12 and is in quadrant 2. What is the value of secant theta? Okay, so again, we're going to start by setting up my triangle in the correct quadrant. So that's step 1. So I'm in quadrant 2, which means my triangle looks like this. This is my right triangle. This is my theta. Okay. Now, we know from the last problem, the ratio tangent theta is y over x. So my y is 5. So this is 5. And this is 12. Now, this is negative right here. One of these has to be negative, because they both can't be negative, because both of them are negative, you get a positive number. So one of these has to be negative. Well, we're in quadrant 2. In quadrant 2, is the y value negative or the x value? Well, the x value is negative. So we know this is negative 12, and the y value is positive 5. And that makes sense, because 5 divided by negative 12 is negative 5 over 12. Now, secant. My secant ratio. That's what I'm trying to find. Well, what is the ratio of secant? It is r over x. Okay, it's the reciprocal of cosine. So when we go back over here and we look at secant right here, secant theta is r over x. So I already know what x is. So secant is going to be something over negative 12. So again, I've got two sides of a right triangle. How do I find the third side? Well, we can do Pythagorean theorem. So again, a squared plus b squared equals c squared. Okay, so you get 5 squared plus negative 12 squared equals c squared. So you get 25 plus 144 equals c squared. And then 25 plus 144 is 169. So the square root of 169 equals regular c. And this should be plus or minus, which means c equals plus or minus 13. Well, again, we're finding our r, right? So can r be negative? Nope. So we just have to worry about the positive 13. So we put positive 13 here. So again, our secant is r over x. R is 13. Now, the other thing that you need to start realizing is that a lot of times we use these Pythagorean triples. Like in the last problem, it was 3, 4, 5 triangle. This triangle is my 5, 12, 13 triangle. Okay, these are perfect Pythagorean numbers, which means when you plug them in Pythagorean theorem, you get no decimals. And that's why we call them Pythagorean triples. The hardest part about this problem is making sure that you set the triangle up in the right quadrant. Okay, and you make sure that your actual trig value works out, because secant should be negative in the second quadrant, and it is, just like cosine. Okay, that's our trig values.